So Haydn consistently plays against this high expectation of the MIDI rate. I'm just going to skip ahead here to give time for Dan.
Well, you have to talk about Montague though.
Oh, we'll get that. So I just want to suggest that, and again, what's interesting to me is that expectation has no real jargon. It has no real technical set of descriptors. So I want to think about the idea of what to expect. And here's an example of sort of a rhetorical device that Beethoven uses in terms of swapping what to expect. So this is the alla tedesca movement of Opus 130. Here's the theme. Beethoven simply takes the theme, cuts it up, tosses it in the air, takes it back together in random order, right? Completely subverting the sense of continuity, but keeping the same set of what should happen. So what should happen is highly expected. Where it happens is not. And the biggest set of expectation violation is when things will happen. Anne Fernald's wonderful study of peekaboos, universal sort of cross-cultural peekaboo study, underscores this, the strong sense of knowing that something is going to happen, but not knowing when it's going to happen. Let me just zip forward and end here. But I actually want to end with something that just came out today. So, you know, Benon and I have been teaching a graduate, not really a class, sort of a reading group that's been going through the standard literature on neuroscience and music. And we started by recreating the stimuli of some of the classic experiments. And then we ended up running one experiment, building one classic ERP experiment on expectation. And the experiment is, it was done by many people under many circumstances, most recently Stefan Kolsch redid the experiment with live music performance so that it's not sort of laboratory pristine. And the experiment is a set of harmonic progressions where the last chord is a violated expectation, and trying to see the response of the brain to that. So we recreated that experiment, but we added one. So here's the standard. Here's the second one. That wasn't done before, where we repeated here's a violation, and here's another violation. And here's the one we added that hasn't been done before at all. Aha. Now that's a really interesting one. So it's interesting because most of the studies that have been done on expectation violation really center around the what, but not the when, right? And so this is entirely not for, if anyone's, turn that camera off. Do not record this. This is not science whatsoever. This was done as a class project with a small set of subjects, so there's nothing publishable here yet. But, and honestly, we just expected this to be a teaching tool for the class. But what did come out of it was, if you look at if you map the violations, so C major is the expected end. This silence, that last one that we added, has an absolutely pronounced difference. It's happening about 150 milliseconds later, and it's happening with a much stronger sense of activation.
What are the data? Are these ERP data?
This is ERP. So this is what's known as the P3. This is the standard N1. This is what is often looked at in terms of expectation violation. And the P3 here for this silence really says something that's pronounced. And in fact, doesn't seem to have been noticed and said before at all. So you're getting a preview of the next little bit of study that we're going to be doing.